So with what we've done so far, we've been able to solve most equations, but we haven't been able to do things like in general, just whatever. It's been very specific cases, like where we have just one variable off to one side, or when we subtract variables, it's usually not all that bad. Right now, we're going to combine everything into these equations. So we're talking about general equations. Specifically, what I mean are equations of the form ax plus b equals cx plus d. Now that might look kind of fancy because I have a whole bunch of letters going on up there. Here's what I mean by this. All I mean by solving equations of this form is you have the same variable put on both sides of your equation. So I have variables here and I have variables here, and we want to learn how to deal with those things. I think you might have had a couple of those on your homework, as a matter of fact, but I want to give you some general steps on how to solve these. You ready for it? So here's what we do. Here's an example, like a real example without all these letters up there, of things that we can work with in this section. So let's say we have something like 5z minus 4 equals 8z plus 5. I'm going to give you some steps right now that are going to be the steps that are going to stick with you all the way through whatever math class you take. These are going to be the same steps for solving equations. Everything will come down to these 3 steps. That's kind of nice, right? That's pretty important. So if we have these 3 steps down, we're good to go. Here's your 3 steps on how to solve equations whenever you get them. First step. The first step is you have to simplify, which means distribute, and combine like terms on both sides of your equation first. So number one thing you look for is to simplify and combine like terms on both sides of the equation. Excuse me. Thank you. Hey, let's try that. Look it up at our equation. Do we have anything to simplify? Do we have anything to distribute is what I'm asking. Do we have anything to distribute here?
Yes. Yeah.
Distribute means there would be some parentheses. Do I have anything to distribute?
No.
Okay. Do I have any like terms?
Yes.
Before you answer that,
No.
remember that like terms are on the same side of an equation. Do I have any like terms?
No.
No. Step 1's done. I don't have anything to distribute. I have no like terms to combine. So this, ladies and gentlemen, is what you're looking for. You want something like this, where you've got variable plus or minus number equals variable plus or minus number. You with me on that? That's the idea. So step 1 will get you down to this spot. Get you down to right here. So on step 1, we don't have any distribution. We have no like terms to combine. So step 1's done. We're good to go. Step 2, here's where the work comes in for us. What you're going to do is eliminate the smaller variable, and it will always be by addition and subtraction. Eliminate the smaller variable, it will always be by addition and subtraction. So we've already looked to distribute, we've already looked to combine like terms. We couldn't do any of that stuff because we didn't even have like terms, but now we can look for the smaller variable. What is a smaller variable here? 5z is a smaller one. We have 8z, we have 5z, so the smaller variable is what we get rid of first. We don't want to mess with the constants right now. Don't mess with the numbers. You see, if we start moving these numbers around first, what happens is sometimes we do it the wrong way, and then we have to get rid of a variable, and then we either get stuck because we have 0 on one side, and you're like, I don't know what to do with that, or you have to move the number back anyway. So firstly, find out where your variable is going to be sticking. Find out what side it's supposed to be on, and then work from there. Does that make sense to you? So firstly, get rid of the smaller variable. In our case, our smaller variable is 5z. How do we get rid of the 5z in this case? Yeah, it's always going to be either add or subtract when you're moving a variable. So for us, we are certainly going to subtract 5z. We do that here. We do that here. Whatever you do to one side, you do exactly the same thing to the other side. That has to be that way. And we notice that by doing that on both sides, we actually create some like terms. Now these things, look at the board, these things are like terms. Now these things are like terms. They're now on the same side. That's how we move variables around. Can you please tell me what we are going to have remaining on the left-hand side of our equation?
-4.
Good, it goes with the sign, so -4 is correct. Equals, on the right-hand side, we're going to have what?
3d for z plus 5.
Perfect. Perfect. As soon as we get rid of our smaller variable, you're going to have something like this. The equations are going to look the same every single time you do this. You're going to distribute combine like terms, you will get something that looks like that. You're going to get rid of the smaller variable, you're going to get something that looks like this, where now you only have one variable, but it might be surrounded by some numbers. Now is the part where we get rid of those numbers. That's what we ended with, what your homework was on last time. Which number do we get rid of? Now, I'm not talking about the -4. There's no variable over there. That's fine. What I'm talking about are these two numbers. Which one do we get rid of first?
5.
The 5 or the 3 first?
5.
The constant term first, and yes, we're going to subtract it. So, after you eliminate the smaller variable by addition subtraction, the next step you're going to do is eliminate the constant term by addition subtraction. The constant term, again, is the number being added or subtracted after your variable or before your variable. It's never the number attached to your variable. And Jeff, what did you say we do?
Subtract the 5.
Okay. If we do that from one side, we also have to do that from the other side. Okay, ladies and gentlemen, tell me what we're going to have on the left-hand side of my equation.
9.
How much?
8, 9.
Good. How about the right-hand side of my equation? Good, because those 5s, those create a 0 for us. We don't have to write that down. We're almost done. We don't want to leave it 3z, we want z. So tell me what's the last thing you're going to do?
Divide by 3.
Yeah, the last step is always to divide. If there's a number in front of your variable, the way you get rid of that is just to divide. So the very last step for us, step number 4, you're going to eliminate the coefficient. Remember that word coefficient? I've had you say that in here before, right? Coefficient. That's right. Good job. The coefficient is a number in front of the variable that we divide out. It's being multiplied by your z, so to eliminate that, we divide. So eliminate your coefficient by usually division, sometimes rarely multiplication if it's a fraction or if it's over a number. Eliminate the coefficient by multiplication division. So in this case, yeah, we're going to divide. We've had these problems before in this class. So we're dividing by 3 on both sides. On the right-hand side, our 3's create that 1 for us. That's how they eliminate each other, and we get simply a z. On the left-hand side, we get what, everybody?
-3.
Perfect. That's exactly right. That's the way we solve general equations. We simplify, we get rid of the smaller variable, then the constant, and then lastly, the only time we divide is when we're removing that coefficient. Let's do one more together. I'll give you a couple to do on your own, and then we'll start building these problems up little by little, okay? I'm going to ask you the same few questions every time we do a problem today. First thing, do I have anything that I can simplify first? Nope, there's no parentheses, there's no, are there any like terms?
No.
Why not?
They're not on the same side.
Very good, excellent, you're starting to see that, that's excellent. So my very first step should be to remove or get rid of or eliminate the smaller variable. Do you guys see the two variables?
Mm-hmm.
Now, before you answer, I want you to think about this. Don't just shout out an answer. I'm going to ask you, what's the smaller variable? But before you say it, I want you to notice that variables also contain the sign in front of them. It's a term, right? So it contains a sign. So when we look at these variables, yes, I see the r, but over here, that's not just 3r. It goes with the sign in front of it. It's negative 3r. We're going to consider that to be negative 3r because we could write it as plus negative 3r. You with me on that? So which one's smaller, r or negative 3r?
Negative 3R.
Definitely negative 3r because that's negative. It goes with that sign. So we consider it positive negative. That negative is definitely smaller than 1r. Negative 3r is smaller than positive 1r. Are you with me on that?
Yeah.
Now, will it come out the same if you subtract r from both sides? The answer is yes. Yeah, it will eventually come out the same. However, I'm going to try to make it easy on you guys. And the reason why I give this step is because if you always eliminate the smaller variable, you will never have to divide by a negative. That's nice, right? You never divide by a negative. You get rid of that negative. So when we look at this thing, we say, which one's smaller? It's not the r, it's a negative 3r. How are we going to get rid of that minus 3r? What are we going to do to it?
Add 3.
Plus one. Adam. Plus.
Yeah, add it. We're going to add it. Jeff, you had a question?
Yeah, I was just wondering. Oh, okay, never mind. I get it. I was just wondering
Easiest
how-
question of the day, Jeff. Love it.
Shit.
So when we take a look at our problem, we're identifying the smaller variable. You always eliminate your smaller variable by addition and subtraction. So when we look up here, we go, okay, how are we going to get rid of minus 3r? We're just going to do the opposite of that, plus 3r. But we have to do it to both sides. All right, tell me what we're going to get on the left-hand side of my equation here.
4r.
Good, yeah, that counts as 1r. Perfect.
Minus 7.
Equals?
5.
5.
Beautiful. Now we're down to something that we can really work with. What number are we going to get rid of next, please?
7. Negative 7.
Notice how we're not dividing till the very last step. It's just addition. It's combined like terms, which this is already done for you. Add, subtract, divide. It's always going to be add, subtract, divide. Divide comes last. So we're going to add 7 to both sides. 4r equals, well, that's going to be 12 for us. And our last step is to get rid of that coefficient by division. So we're going to divide both sides by 4. And that's it. Hey, can you still check your work, by the way?
Yeah.
Sure. If we plug that in, we'd have 3 minus 7, that's negative 4. We'd have 5 minus 9, that's negative 4. That comes out the same.
Yeah, I subtracted the 1r.
Yep.
I still got the same answer.
Right, that's exactly what I was saying just a little while ago.
So does it?
I was just telling you, like maybe 30 seconds ago, that will it work out the same if you subtract the r instead of add the 3r? And my answer was, yes, it will work out the same. It has to. It's an equation. Once you do to one side, you do to the other side, it will work out. The problem is, when you do that, you're dividing by a negative, and sometimes that messes up a lot of people. So what I'm doing here is I'm making this easier for you. I'm saying get rid of the smaller variable, that way you don't have to divide by negative. Are you clear on that? So will it work out the same if you subtract r here? Yes. Will it work out maybe a little bit easier for you by not dividing by negative if you get rid of the smaller one? Yes. Probably a little bit easier. That's why I have you do that. Are you ready to try a couple on your own?
Yeah.
I'm going to put one over here. When you finish that one, I'll have that erased. You'll have another one over there. You do subtract 2c. And you get 5 equals 6c plus 2. And you do subtract 2. And you get 3 equals 6c. However, what are you dividing by? 3 or 6? So if you divide by 6, you get 3 over 6. That is not 2. 3 divided by 6, you say, oh, what's 3 taken into 6 parts? That ain't 2, right? It's actually a fraction. We haven't covered that in this class. So this would be 1/2. 3 over 6 is 1/2. That's the answer. Or you can do it in a calculator and get 0.5. So that's why I couldn't give you that problem. That's why I had to change it originally. I just messed up the one I changed it to. Okay, let's move on to this one over here. So we draw our line signifying that we do, in fact, have an equation with two sides. What variable are we getting rid of first, ladies and gentlemen?
Negative 2x.
Negative 2x.
Good, because that's our smaller variable. So we get rid of the negative 2x by what?
Adding.
Good. So we'll have what on the left-hand side? Good. We have that sign still. That's important. On the right-hand side, how much do we get?
11x minus 18.
As soon as we get rid of that smaller variable, then we have something we can work with. So we get rid of our constant term. What's our constant term here?
The 18, the negative 18.
How are we going to get rid of that?
Add 18 to both sides.
On the right-hand side, I get 11x. On the left-hand side, I get
11 positive.
And if I divide both sides, what do I divide by?
11.
Well, on the right-hand side, we get x. Sure, because the 11s are gone. But wait a second. What's 11 divided by 11?
1.
Good. We got 1. Say x equals 1. Because that's an equation, so we do have to have the equal sign.
Can you write X?
Well, we did write x.
No, by itself?
No, because you have an equation, right? X has to be equal to something. So we got x equals to 1. We leave it x equals 1, and we're done with that. How many people feel okay with at least this example? Good. All right. Let's move on. Okay, we're going to start building these up little by little, making them a little bit more complicated for us. Are we going to be able to do them? Sure. You know how to do all the stuff. You know how to do everything. I'm really not teaching you anything new, except get rid of the smaller variable. That's it. But you need to tell me what I need to do first on this problem. What should I do?
Combine 6a and negative 9a.
Perfect. So when I combine those, I have some like terms, as a matter of fact. So before we start doing all this stuff that we've been practicing now, you have to make sure it looks like that. You got to make sure you combine your like terms first. In our case up here, yeah, we do have some like terms. Not on the right side. We can't do anything with that. But on the left-hand side, yeah, I see the 6a, and I see the minus 9a, or the negative 9a, which is what we're going to consider it as. How much is that going to make when I combine those like terms?
Negative 3a.
Notice how we're combining like terms just like we did like several weeks ago? We're just using that stuff.
Is this one going to be wrong too?
I don't know.
Because I'm getting 3 equals 6a
Yeah.
plus
That's
7.
fine.
And then
That's
you'd have to subtract 7.
That's fine. We'll talk about that. I planned on doing that on that example, not on that one. So we'll have 3a plus 7. What are we going to do now? Now that we've combined our like terms, what do we
Get
have?
rid of the
Get
smaller variable.
3a.
Good. What is our smaller variable in this case?
3a.
Wait, 3a or negative 3a? Because I see both.
Negative 3a.
How are we going to get rid of it?
Add.
On the left-hand side, I get 3. On the right-hand side, I get,
6.
and then a plus 7. Okay, what now? Keep going. Sure, let's do that. If we subtract 7, which is our constant term, I'm going to get negative 4. And you go, wait a second, this is like the last problem. Well, I put this one up here on purpose because that I didn't know if we were ready for it, but here we're ready for it. If we divide by 6, that is your step, right? You're trying to get rid of that 6 there. You're trying to eliminate that coefficient. If we divide by 6, watch what happens. Here the 6's are gone and I get a. True?
Yes.
What do we have on this side? Well, it doesn't work out to anything even. It doesn't work out to anything nice. Just leave it as a fraction. It's going to be okay to get fractions. As a matter of fact, after the next section, we jump right into fractions. So this is a good kind of preview for us to get some fractions out of this. So when we divide and it doesn't go in evenly, negative 4 divided by 6, just leave it negative 4 divided by 6. Okay, I haven't taught you how to reduce yet, so you don't have to reduce it. If you do know how to reduce it, great, reduce that. That's negative 2 over 3. But if you don't know how to reduce it, leave it. Leave it as a fraction. Our fraction's okay to get. Say yes.
Yes.
Our fraction's okay to get.
Yeah.
Yeah, so if we get 1, no problem. Our answer is negative 4 over 6. Eventually we'll be able to reduce those, but for right now we'll leave it negative 4 over 6. Raise your hand if you feel okay with that one. Good, all right. Okay, we'll do one more together. We'll do a couple more together. I'll give you 2 more to do on your own, and then we'll start moving on. All right, let's go for it. Let's go for it. First thing we gotta do, look for any like terms that we have to combine. So if there's no distribution, we're looking for like terms. Do we have any like terms on the left-hand side?
Yes.
What are they?
40 and 5.
So if we combine 40 and 5, how much do we get?
45.
And I still have a minus 5y, that's gotta be there. On the right-hand side, do I have any like terms? Sure, yeah, I see it.
Negative 2y and negative 4y.
Perfect. If I combine my negative 2y and my negative 4y, I get...
6y.
5, 9, 10.
Perfect. Yeah, that's right. Do I have any more like terms to combine?
No.
Okay, now watch carefully on the board here to save us some issues. When you're looking for your smaller variable, you do consider the signs with those numbers. So I want you to notice something. Up here on the board, we have a negative 5y and we have a negative 6y. Those are my 2 variables. Yes?
Yeah.
Which one is smaller?
Negative 5y.
Negative 5, 6y.
Which is smaller? Negative 5 or negative 6?
Negative 6.
Negative 6 is smaller than negative 5. Let's get rid of negative 6y. Now here's why. You're like, why does it matter? Well, if we get rid of negative 6y, we're going to have a positive y. We won't have to do any more work with that. You with me on that? If you got rid of your negative 5y, you'd have a negative y. At the very end, it's very hard to think about what negative y equals. If negative y equals a number, what does y equal to? And you have to divide by a negative or move the negative over. So if we eliminate the smaller variable, oftentimes we'll eliminate a step. Does that make sense? So let's stick with the smaller variable here. So our smaller variable is negative 6y. How are we going to get rid of negative 6y?
Add.
We get 45. We get, oh, what's this going to be?
Plus y.
Plus y. I'll tell you what, on the test, when I give you your second test, you're going to have lots of these problems. This is where people have an issue, right here, is doing this type of problem. This one, people get that, people get that. It's doing this sort of stuff with, you have a negative and a negative. A lot of people have issues with that, so really focus on getting this stuff right, making sure we're using the addition rule. Make sure we're getting rid of the smaller variable. Addition rule says different sign, subtract sign, the bigger number, that's positive y. On the right-hand side, we get what?
Negative 10.
Hey, tell me something. What number do we have to get rid of now?
45.
45.
How?
Minus.
Subtract it.
So if we subtract 45, I know on the left I get y, on the right I get... Is that what you got? Negative 55?
Yep.
That is it. Now, I want to show you something, okay? Let's say that you don't listen to me and you just kind of, or you forgot this, and you got rid of the minus 5y first. Let's say you added that to both sides. You with me? What you're going to get at the end of your problem, you would get negative y equals positive 55. If you had done that, a different step here.
Why is negative 6y smaller though?
Well, which one is smaller between these numbers? Negative 10 and negative 1. Which one's smaller?
Negative 1.
If you put
Look
them
at
on,
the chart.
It's negative 10.
Yeah.
You gotta go back to the number line.
if you put them on a number line, here's how you tell which numbers are smaller, right? The numbers to the left are smaller numbers. This would be 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Then negative 1. than negative 10. So which number is smaller according to negative 1 and negative 10? Negative 10 is smaller. Here's how you figure this out. If negatives are owing money, which one do you owe more money? I owe more money with the negative 10 than I would with the negative 1. So at the end of the day, owing this amount of money would put me more in the hole than this one. I'd have less money here than I would there. Therefore, this one's smaller. So in our case, which is smaller between negative 5 and negative 6? Negative 6 is definitely a smaller value. Is that clear for you? Okay. That's why. Now, and you go back to this. Let's say that you happen to add 5y. What you'd get on this problem, actually it'd be over on this side, you would get 55 equals negative y. I can't afford to have you leave that. I'm not looking for negative y. I'm looking for y. So if we're leaving this as negative y, we really don't have the concept down. If we understand that, okay, 55 equals negative y, how do I change that to a positive? Well, you got to consider this is really like negative 1, right? Yes, no? If that's negative 1, I could divide both of these things by negative 1. I get negative 55 equals y. That's the same exact answer. So yes, you can do it. It's possible. But oftentimes, getting rid of the smaller variable will eliminate the need to do that altogether. Raise your hand if you understood what we just talked about. Good. Good, good, good. Hey, could you manipulate that? Could you distribute and combine like terms on that problem? I know you can, right? Because we've been practicing that a long time. Now, all I'm going to do is say this is equal to 0. Let's go for it. Let's see if we can do this thing. What's the first thing that we're going to do on this problem, ladies and gentlemen?
Parentheses.
Good, parentheses, which means how do we get rid of parentheses in this type of a problem?
Multiply.
Yeah, multiply means, what's that D word?
Distribute.
Yeah, we're going to distribute that. We always distribute the number in front of the parentheses with the sign. We're going to take it to not just the first one, not just the second one, but both of these things. Y'all tell me, what are we going to get when we multiply 3 times our 2x?
6x.
And the next thing is?
Minus 18.
Good, I like it. Minus 18. And then this plus 6 is still hanging on, and we have the equal to 0. What's the next thing you're going to do? Good, and I have some. I've got a negative 18. I've got a positive 6. That means I'm going to get 6x minus 12. Oh.
Divide.
Well, wait a second. I've got 6x minus 12 equals 0. I've already distributed. I've already combined like terms, but I don't have 2 variables here. So what happens if you don't have 2 variables? Well, then you skip that step. If we don't have 2 variables, there's no smaller one to get rid of. This is already set up for us. We just need to go down to the next step, get that x by itself, or get your variable by itself. Which number do we need to get rid of first?
Negative
12. So even though there's not a number over here, that's okay. It could be 0, that's fine. That makes it even easier. We just have to get rid of these 2 numbers now. So to do that, how do you get rid of that minus 12 again?
Add.
Let's just add 12 to both sides. I get 6x equals positive 12. And our last step, ladies and gentlemen, is to do what?
Divide.
If we divide by 6, x equals
2.
That's it. That's our answer. So even if you don't have 2 variables, one on each side, that's actually kind of easier for you. You just skip that step, get rid of your constant term, and then divide. Are you ready to try a couple on your own?
Yeah.
Sure.
Okay, let's do that. Hey, by the way, I'm going to stop right now. I'm going to point something out to you. I see a lot of this when people are first learning how to do this type of equation. I see a lot. Watch on the board. Put your pencil down for just a second. Just watch, okay? What I see a lot of is people confuse this step with combining like terms on this step. And they do something like this. They go, oh, okay, Well, if I have a 5a here, I'm going to subtract 5a from both of these things. Okay, I see that a lot. I see, or they think, well, I'm adding 5a here. That's what I want to do. But typically, it's the subtract. People subtract and they go, that's what I want to do. Is that what we want to do you think?
No.
Look what this does. Look, I want you to really understand the concept of your equations. You ready?
Yeah.
If that's an equation, look what you've done essentially. You've just subtracted 5a twice from one side and no times from the other side. You see that? You've really overloaded one of these sides. This is not level. What you have to make it is, notice how these are on different sides. That's what we're looking for. In order to do this process correctly, you have to first combine your like terms. We can't start doing this nonsense because you're going to overload one side. Firstly, we go, okay, let's circle them, let's combine them, and then we can work like this. Do you see the difference between these two problems? Yes?
Yeah.
Okay, make sure we're doing it the way we're supposed to. Okay, go for it. Do that problem, and I'll write one more up on the board over there.
What's negative 2 plus 2? Keep going. Is it okay to get 0?
Yeah.
Why not?
Yeah.
Anything times 0 is 0. No matter which way you go.
Did I stump you on this problem? I stumped some people. A little bit. On some zeros, huh? Yeah. What's going on with those zeros? Well, let's see. Hopefully you made it down that far. If you did, you know what you're doing. So if you know what you're doing, what you should be doing is combine some like terms. Did you combine some like terms?
Yeah.
Good. So this would give you the 9a minus 2. This would give you, we're just combining like terms here, folks. It's like you're ignoring this side for a second. You're combining your 4a and your 5a. You're getting 9a. You're ignoring this side. You're combining your 2a and your 3a. You're getting 5a. But in each case, we have minus 2. Raise your hand if you made it that far. Fantastic. The next thing you do, after we've combined like terms, which that's what we've done here, we're going to get rid of the smaller variable. What's the smaller one in this case?
5A.
Let's get rid of it. How do you get rid of it?
Subtract 5A on both sides.
So that's going to give me 4a
Minus 2.
equals negative 2. Now you're supposed to get rid of your constant term. Listen, no matter what you get after this, don't let it ruin your process. I swear the process is exactly the same no matter what equation you are working on. I promise. I told it to you. What you do is you combine like terms. You distribute if you have to. You get rid of the smaller variable. We've done that. You get rid of the constant term. You do that. And then you divide. That is always your steps every time, no matter what you have. Are you with me on this? Just follow that down. So when you get down to this step and you go, oh, wait a second, I'm supposed to get rid of this negative 2, true?
Yes.
And you go, I'm going to add 2 to it. And you go, well, this is clearly 4a, because those are gone. How much do I get over here?
0.
Negative 2 plus 2, that's 0. Is it okay to have a 0? Yeah, it's okay to have a 0. What are you going to do next?
Divide.
That's always your last step if you have a coefficient. But if you divide 0 by 4, a is going to be on the left-hand side. How much is 0 divided by 4?
Divide.
It's not undefined. That would be if you divide it by 0. You'll never have to divide by 0. Okay? If you have 0 divided by a number, here's what this says. I'll go through it the last time with you. If you have $0 and you spread it across 4 different bank accounts, how many dollars is in each bank account?
0.
There's nothing there. There's 0. This answer is 0. 0 divided by anything is 0. Does that make more sense to you now?
Yeah.
Let's work on the next one. Next one says, well, we got to distribute first. We're going to take 4x plus 12. Did you get 4x plus 12? Plus 1 equals 13. We'll combine some like terms. 4x plus 13 equals 13. And we have the same situation. If we subtract 13 on both sides, we are going to get 4x equals 0. Same 4x. Weird. If we divide by 4 again, we're still going to get x equals 0. So in our case, we got 2 zeros. It's okay to get zeros. It's okay to get fractions. We haven't really worked with a whole lot of fractions, but for right now, we're just going to leave them as fractions. Raise your hand if you feel okay with these 2 examples. Good. 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 Hopefully you learned something there on that one. Now we'll try one more together, and then we'll start practicing a few more of these next time. We'll do a whole bunch of translating, and that'll be our class next time. So one more. I want your help with it, though. Let's see if we can work all the way through on one problem so we can put everything together. Can you do that?
Yeah.
Yeah, sure. Have some comments about it. You know how to do that stuff. Are you going to subtract 6 minus 2 first?
No.
Heck no. Can you do that?
Yeah.
That one? You can do that, right?
Yeah.
Now I'm just saying they're equal. It's going to be the same process we just did. Same process we've learned a long time about distributing, combining like terms. It's just now we have to do those things before we attempt to solve our equation. So can you tell me what is the first thing that we're going to do on this problem?
Parentheses plus.
Good. Parentheses means we're going to, what's that D word again?
Distribute.
Can you tell me what we're distributing in the first expression?
Negative 2.
Negative 2 times 3x.
Good. It goes with the sign. So we're going to circle the number with that sign. Oh, let's be careful on this. Can you tell me slowly what's the first number I write?
Negative
6.
6.
Well, 6 is going to be the first thing because I didn't change that. What's the next thing I write?
Positive 6.
Positive
Negative
6?
6x.
Negative
Negative
6x.
6x.
Good. Negative times a positive is a...
Negative.
Now, is it going to be plus 2, minus 2, plus 1, minus 1? Which
Plus
one?
Plus 2.
It'll be plus 2, plus 2.
We got to multiply. Negative times a negative gives us the plus. 2 times 1 gives us 2. You with me, folks?
Yeah.
That's a big one. This is the part where people make a mistake. That's it. Usually this is right, this is right. The other side's right. It's usually right here. If you get this part right, chances are you're going to get the problem right. This has to be plus 2. Negative, negative, positive. On the right-hand side, Now we got something we can really work with. What are we going to do now?
Combine like terms.
Sure. So we're going to do our 8 from our 6 and our 2.
8 minus 6x.
We're going to do our 9 and our 5. We'll get 14 minus 3x.
Then you're gonna eliminate the smaller variable.
Sure. Which is the smaller variable here? Still on the left-hand side of the room. What's the smaller variable? Perfect. We've got 8 equals 14. How much is negative 3x plus 6x?
3x.
3x.
Good. We're almost done. Can you tell me what's the next thing we're going to do?
Minus 14.
Good, that's our constant term. We do subtract that from both sides. Negative 6 equals 3x. And last step, everybody, what's now?
Divide.
Good. If we divide by 3, how much are we going to get?
Negative 2.
Hey, I'm pretty impressed with your homework so far. I'm pretty impressed you guys are catching on to this so far. You're doing really well. Do you feel like you're doing real well at this?
Not on the last homework.
Not on that one? Go back and look at it again. Is that the one where we translated?
Yeah.
Yeah, that one's hard. How many feel okay with what we talked about today? Feel okay about it? Good. We'll practice more of this next time. So, we're back to doing general equations, and what we're realizing is that this section pretty much ties together all of our combined like terms, our distribution, our addition rule, our multiplication rule, division rule, all that stuff. It's putting it together for us, and we're able to solve equations. So it's quite a big section for us. And we're working on problems like this one. So if we're supposed to solve a problem like this, which can only be done if we have an equation, thankfully we do, what are we supposed to do first before we start adding or subtracting or multiplying to both sides, all that stuff? Say what now? Distribute, combine like terms. Sure, good. So we're actually trying to simplify both sides before we start working with the equation itself. So it's kind of like miniature problems within this problem. We look over here, we try to simplify just this part. The 15, we're going to leave that alone. That's just a number. But yeah, we do want to distribute this side first. Now, how about this? Do I subtract first or do I distribute first?
Distribute.
Definitely. Now, what number am I distributing here?
Negative 3.
Good. Circles with the sign. We've done this a lot now, so this should be becoming pretty easy. Well, not easy for us, but a little bit more understandable, a little bit more doable for us. We do write the 4. Can you please tell me what I'm going to get when I distribute negative 3 and t? So I'm going to put minus 6t. And then what's this one? Plus or minus?
Minus.
Good. Equals 15. So we distribute, we get this. Now what do we do?
Combine like terms.
Perfect. When I combine like terms, I'm talking about on each side. So on the right-hand side, I'm not even worried about like terms over there. There's just one number. Over here, I do have some like terms. I see the 4. I see the negative 3. If I combine 4 and negative 3, what do I get?
1.
1 and then what? Perfect. Now we double check. We make sure we don't have any more like terms. We don't have any more like terms. We're good to go. We're ready to solve this. Our variable is t, and so what we try to do is get everything away from that t. So in our case, we have to get rid of a coefficient and a constant. Which one do we get rid of first, the coefficient or the constant?
Constant.
Good. How are we going to get rid of that constant?
Subtract 1 from both sides.
What's on the left-hand side, please?
16. Negative 16.
So we have to keep that sign with it?
Yeah.
Okay. On the right-hand side?
14.
Notice in this case we didn't have two variables on either side. We didn't have a variable on each side. So there was no way to make our variable positive. If we had two variables, we would have been subtracting this or adding the smaller one. Do you remember doing that as well? So when you have two variables, that's the case. In our case here, we didn't have two variables. We could only isolate this variable. So there wasn't any smaller variable to get rid of. We look at our t, we get rid of our constant term, Now we're going to get rid of the coefficient. What is my coefficient in this case, folks?
Negative 16.
So what do I divide by?
Negative 16.
So negative 6. Am I dividing by t in this case?
No.
No.
No, we want to leave the t there. I'm just doing that negative 6 because all I really care about is getting rid of that number. On the right-hand side, oh, wait a minute. Does negative 6 go into 14?
No.
No, we're just going to leave it. Leave it 14 over negative 6 for right now. I will show you what to do with those fractions in the next section, in 2 sections from now in chapter 4. Raise your hand if you feel okay with doing that problem. There's a little review for us. Good deal. Now I'm going to give you 3 to do on your own. I'd like you to work through them. I'll be walking around. If you need help with this stuff, now would be a great time to get that help. Just to let you know, you are going to have several problems like these on your second test. Make a little note on that so you go back and study those problems. You're going to have lots of those. So the first thing we're doing is trying to simplify both sides of our equation. Simplify both sides. That means you might have to distribute. You might have to combine like terms. After that, we look to see if we have 2 variables. If we do, if we have 2 variables, we get rid of the smaller one. We're talking about 2 variables on different sides of the equation here. We get rid of the smaller one. Then we get rid of the constant term by addition and subtraction, and finally we divide. That's our process. Yeah, that looks right. Okay, we're going to get started on the first one here, then I'll give you a couple more minutes on the last two. But I want to make sure you're doing this correctly. So on the first one up here, first thing you need to do, of course, not subtract. We're not doing 6 minus 5. We're distributing because the order of operations say multiplication comes before subtraction, so we're distributing first. We're also distributing not only 5, but we're distributing -5. You have to circle that number with the sign. That's why I have you do that step, so you identify that that minus or that negative is going with that number. Not sure if you're with me on that. That's got to happen. So we do have the 6. We're going to have minus 15y. Everybody's going to get that part right. Even if you distribute just regular 3, you get the minus 15y right. It's the second part that's crucial for you. If we distribute -5 times positive 2, you need to be getting minus 10 there. Did you get minus 10?
Yep.
Good. And that equals 26. Now from here on out, we're going to try to combine like terms and keep on simplifying this until we get no like terms left on either side. So we have a 6 and a minus 10. I know that 6 and minus 10, that's going to give me 4? Negative 4. Oh, okay, -4. -4 minus 15y, I still have that, equals 26. Everything's combined. I have no more like terms. Now it's time that I can solve for my y. I get rid of my constant term first. What's my constant term that I'm talking about here?
-4.
Good, so I need to add 4 to both sides. That gives me -15y equals 30. And then from here, do what now?
Divide.
Our last step is always to divide. That number in front of y is called the coefficient. The only way you get rid of a coefficient is through division. So we divide by what? Yeah, is it 15 or -15?
Negative.
That's how we're going to get rid of that negative. So -15 on both sides. Y equals, what's 30 divided by -15?
-2.
Dividing that, yeah, we're good to -2. Raise your hand if you got -2. Good, okay. Okay. Do you need more time on this one? Let's go through this one then. What's the first thing you're going to do? This is quite an involved problem, isn't it? There's a lot to do on this problem. First one is what now? We'll distribute this. So we'll leave our 5x alone. Can you all tell me what number am I distributing here?
-3 times 2.
So I'll circle that. Let's see what we get. It's going to go to both those terms. Everybody, what's the first thing I'm going to have?
-6.
That wasn't everybody. Come on, folks. Let's play along.
-9.
-6x. And then -9 or +9?
+9.
Can you explain to me why +9?
2 negative.
Good job. On the right-hand side, I have a +4. I'll distribute that. I know I'm going to get 4x minus 8. Would you please raise your hand if you made it that far? Okay. The next step gets a lot of people with mistakes. The next step. The next step is to combine your like terms, right? You with me still?
Yes.
Next step is to combine your like terms. We've already distributed. Next step is combine like terms. Over here, check it out. I have no like terms.
-3 times -3 equals +6.
Well, we're multiplying.
Yeah, it's just multiplying both a negative and a negative equal a positive.
Right.
But I'm talking about -6.
-3 times 2.
3 is higher than 2.
Okay. Good question. That's all right. So at this point, we're trying to combine like terms. Here we have no like terms to combine. We're okay. Over here, we do have some like terms to combine. Can you please tell me what are my like terms I'm looking at combining?
5x.
Wait. 5x and what?
-6x.
If you combine those, you've got to be using the addition rule. It's the only way we combine like terms. What's 5x combined with -6x? -1x. 5 minus 6 is -1, right?
Yep.
So we should be getting out of this -x. That stands for -1x. You're still okay. Okay, that's kind of a big deal. This is where people make a mistake. They give me sometimes 0, sometimes they give me, I've seen a lot of 11s or -11s. I've seen x's, just single x's like this. I see a lot of that, where people mistake the signs on that. We need to be knowing that that is negative x or negative 1x. And then we have the plus 9 equals 4x minus 8. Give a good head nod if you're okay getting down that far. Okay with that? Good, all right. Now, don't get stuck now. Don't get stuck now. We don't have any like terms, but we do have variables on either side of my equation. What do I do if I have variables on either side of my equation? Okay, and that includes a sign, right? So we look at the variables with the sign. What's my smaller variable here?
Negative x.
How do I get rid of negative x? How many x's are we talking about? Negative how many?
1.
So we're really just adding a single x on both sides. That's what we're doing. You're going to get a problem very much like this on your test. If you can do this, you'll be set. On the left-hand side, how much do we have, ladies and gentlemen?
9.
9 equals 5x minus 8.
Great. If we have 4x plus x, we get 5x. Perfect. Hey, let's keep going. Let's keep rolling. Now, look what happened here. We got rid of our smallest variable. That made it so we have one variable on one side. That's what we want. We want to just isolate this one now. True?
Yeah.
How?
Add 8.
Get rid of the 8.
That's our constant term. Of course, yes, I'm going to get rid of that first. We're going to get 17 equals 5x. 17 equals 5x.
Divide by 5.
Our last step is always to divide. You're exactly right. So if we have a coefficient out front, we get rid of that by division. We're going to divide both sides by what?
5.
Okay, so we divide by 5. And what we're going to write, the 5's do cancel out there. Those are gone. We get 17 over 5. We're not going to do anything with that. We're going to leave it as a fraction.
So I got what I thought I did something wrong.
You didn't do anything wrong if you got that. Okay, I want everyone to raise their hand. Everybody raise your hand. Everybody. Hands up. Hands up. Stick them up. Ready? How many people made it? Keep your hands up if you made it this far, okay? How many people made it to this step just right? Keep your hands up. Good. How about this step? Oh, good. That was a big step right there. If you got the negative x, that's really important to me. That's awesome. How about this step? Okay, so if you missed this step, that adding x, that's important. Watch that next time you go through this. How about to this step and all the way down? Fantastic. Very good. Most people, if they make a mistake on this, they mess it up here or here. Those two steps. Those are big for us. Yeah, the last one. Let's see about this last one. Problem is real similar to the second problem. Have you guys finished that yet?
No.
Okay, take another 30 seconds or so, see if you can wrap that up, okay? If you have, see if you can check your answers. If it's a fraction, well, oh well. So remember, we want to distribute first, then we're combining like terms, just like we've been practicing in the previous sections, just doing that. Then we get rid of the smaller variable if there are two variables, then the constant term, and then finally we divide. So in our program right here, when we're trying to distribute, first thing I'm looking at, I'm going to leave this 2w alone, but I'm going to distribute not only 7, but with that minus sign, we're distributing negative 7. So when we do, we'll get 2w for sure. We'll have the minus 21w, And then we'll have, is that plus 7 or minus 7?
Minus 7.
Good, you guys are really catching on to that. So distribution done on the left-hand side. On the right-hand side, we're distributing 5. We need to be getting 25, and then minus 15W. That's right. So far, so good?
Yeah.
Cool. After that, we're looking to combine like terms. Now, while I don't have any over here, I do have some like terms here. When I combine those, how much do I get? Oh my. Now, what do you do if both your variables, like we have here, are negative or have minus signs in front of them? You still want to take the smaller variable. That will make sure your variable is positive and you don't have to divide by negative, because that's kind of annoying. We don't want to make that mistake. So can you tell me, out of the negative 19W and the minus 15W, which one is technically smaller? The negative 19. Think about the number line. The negative 19 is further to the left. That means it's a smaller number. So are we going to get rid of the minus 15 or the minus 19? It's the 19. And we're going to do that by addition. You know, that's a good question. Andrea said, well, you still get the same answer if you do it the other way. For instance, if you add the 15 as opposed to adding the 19. The answer is yes, you will. We talked about this last class. I said your sign will be different. You just have to divide by the negative at the end. That's the only difference. I'm trying to save you from having to divide by negatives, because oftentimes, especially when you get like negative y equals a number, that's where people make a foul up. So I'm giving you these steps because this tends to be the best way for people to go and get the right answer every time. Do you guys get me? So is it possible to do it the other way? Yeah, absolutely. It's possible. Is this way maybe a little bit more concise sometimes? Yeah, it's going to save you some steps occasionally. So here we'll add 19. 19s are gone here. We just get our negative 7. On the right-hand side, we have our 25. And then we have negative 15W and positive 19W. That's giving me what now? Good. Signs are different. Subtract, sign the bigger number. Plus 4W. Notice how we have a positive there. If you had done the other way, you would now have a negative 4W on this side. Maybe you did that. Maybe you got negative 4W over here. That just means you have to divide by a negative 4 at the end and not mess that sign up. You with me on that? Okay. What do we get rid of now?
4.
25. We'll subtract our 25. On the left-hand side, we get negative 32. Right-hand side, we get 4W. And our last step to get rid of a coefficient is always to divide. We're going to divide both sides by 4. And we're done. You will get the same thing if you had done the different step right here. You should have gotten the same thing. If not, you messed your sign up somewhere. How many feel pretty good about these examples? This is as bad as I can make it, man. If you guys can do this, you guys are pretty good. And I see that most of you can, so I'm feeling pretty good about you guys right now. That's awesome. Now, for the last little bit in this section, we start off with some basic translating. We're going to translate some sentences into equations. This is going to lead us into 3.4, where we do some pretty heavy-duty translating. So let's get started on that. Now, we've gone ahead and we've already done some translating of expressions, which just meant we can translate, we just didn't have any equal signs in there. So the only extra thing we're doing in this little piece is we have to learn some words that mean equals. They're on page 182 for you, so go ahead and look at page 182 when you get home or something. But for right now, there's a few of them that you need to know. The few words that mean equals. For the few words that mean equals here, I'm going to give them to you. First one we sometimes see, if we hear the words or see the words amounts to. If we see or hear the words amounts to, so something amounts to something, that means equals. We can also have represents. Represents means equals in a math sentence. Totals means equals. And lastly, the one that really I use a lot and what we see a lot of, the word is. Is means equals, or was for past tense. So is or was. Those two are used a lot to mean equals. Let's start with some basic ones really to get the hang of this, and then we'll move on to some actual things with variables in them. So we'll just do 3 for right now. Let's say the difference of 110 and 80 is 30. We're not going to have any variables right now. I just want to get the hang of writing these sentences out. Remember before we did expressions, what we did was we underlined the special words that mean math. We're going to do the same thing here. So what's one word up here that means math?
Difference.
Difference. Also, the key one that we want to start off with is the word that means equals. Can you find the word that means equals up here?
Is.
Let me tell you something about the word is, or the word equals, or whatever word up here means equals. Did you know that in a word problem, whatever comes before the word that means equals is on the left-hand side of your equation. Whatever comes after the word that means equals is on the right-hand side. Did you know that it separates that for you? So really, all we need to do is identify that word that means equals. In this case, it's is. Whatever's on the right-hand side, that's going to be on the right-hand side of our equation. So if we have an equals, 30 is the only thing on the right-hand side. Now, you already identified the difference. What's the difference mean?
Subtract.
So we're going to look at the phrase before the word is. We're just going to try to write this as a math expression. That's going to be on the left-hand side of our equation. So the word is, or the equals, separates our equation. Whatever's after the is goes on the right. Whatever's before the is goes on the left, and we try to make an expression out of that. Fortunately, we've already done stuff like that. So what's the difference of 110 and 80? Which one comes first, 110 or 80?
110.
Good. And we're subtracting 80. Let's verify that. Is 110 minus 80 equal to 30?
Yes.
That's our true statement there. So right now we're not dealing with variables, but this gives us kind of a nice foothold to go on. Let's try this. The product of 3 and the sum of negative 9 and 11 amounts to 6. The product of 3 and the sum of negative 9 and 11 amounts to 6. Go ahead and write that down. Let's go through this. Let's underline the words that mean math. First thing though, we're going to look for the word that means equals. Up here, what word or phrase means equals? Amounts to. Okay, so we know we're going to underline that portion of it. Whatever comes before that is going on the right-hand side. I'm sorry, left-hand side. Whatever comes after that is going on the right-hand side. So amounts to means our equals. So somewhere we're going to have our equation, and 6 is the only thing on the right-hand side of that equation because it's the only thing after our equals. Let's go ahead and underline some more things. What else up here means math?
Product.
Good. What does product mean?
No, multiply.
Okay, so we're multiplying. What else? What's sum mean?
Multiply.
Add.
Can I have those backwards?
It's all right.
So product we're multiplying, sum we're adding, for sure. But now wait a second, we dealt with this before. If we ignore this amounts to 6, we already have the equals 6. We're really just focusing on this portion of it. The product of 3 and the sum of -9 and 11. Whenever you saw that, remember how I said the product of 3 and, it should give you a number there. Product of 3 and 6, product of 3 and -2, product of 3 and something. If it doesn't give you a number, what that implies is that you're going to have to use what? You're going to have to use parentheses. So this says the product of 3, that's 3 times, but then it's not like 3 and 6, or 3 and a number, or 3 and something else. It's 3 and the sum of. So this is 3 times. What's the sum of -9 and 11? Let's write that.
9 plus 11.
So we want 3 times this sum, not just -9, we want 3 times the whole thing. 3 times the sum of this. The way you show that is with those parentheses. Most times when that happens, when it says like the product of 3 and then gives you another operation to do, like sum, difference, it's typically that parentheses. That's what that's implying. Now, can you distribute and check your answer? Of course you can. Right? Do you have to? Right now, I'm just worried that you can get this far, okay? In the future, when we get to our equations in section 3.4, we'll be distributing and actually solving them. For right now, I want to make sure you get this. You could verify it, though, couldn't you?
Yeah.
You're going to do -27, 33, combine those together, you're going to get +6. So that does work out for us. Another word I haven't told you about yet, that word up there, can you see the word that means equals?
Yields.
Yields is it. That's right. There are several more. I just gave you the most common ones that we're going to be seeing. There are several more that means equals. So in this case, yields means equals. What's the thing after the yields? So that's the only thing on the right-hand side of our equation. It's going to be -4. On the left-hand side of our equation, we got to underline some words. What words up there mean math?
Quotient.
What does that mean?
Divide.
Good, okay. The quotient of 24 and -6. The quotient of 24 and -6. We're going to write that as a fraction. What number's going to go on top?
24.
Perfect. That's the way quotient works. First number goes on top, second number goes on the bottom. Is that a true statement?
Yes.
And we're okay. We're good to go. How many will feel okay with this basic translating that we're doing? All right. This is actually the end of our section 3.3.